Find the domain first. Of course, this is negative infinity to 0, and this is obviously 0 to infinity. And you will say that for sure the domain of this function is right. All real numbers, no restrictions, no gaps, no jumps, nothing. Of course, 0 must be in the table. I will copy these symbols. Look at the symbols. They are parenthesis to the left now under 0 and bracket to the right. Parenthesis to the left, bracket to the right, and they're touching. Okay. Carefully identify the functions. And if you say, well, I don't need to do this, this is an overkill, I would agree with you. But it's better to put the functions right there on top of the table so you don't replace where you shouldn't. So between negative infinity and 0, because these may not be presented in the correct order. They may be reversed, and then you may plug in the wrong function. So between negative infinity and 0, I have 3. Between 0 and infinity, I have square root of x. Perfect. So let's say for negative 1, when x is negative 1, how much is y? Awesome. When x is 0, and you should say don't, but we'll see in a minute what happens. When x is 0, how much is y? Very good. What about on this side? When x is 0, y is? Perfect. And let's also use 1 and 4. When x is 1, 1. When x is 4, excellent. Remember, the pieces cannot over. Yes, Blaine, go ahead.
How come when it's x is negative 1 on the first side?
Yes, between negative infinity and 0,
yeah.
I can plug in any number. The function is 3.
Why? Well, why wouldn't it be negative?
Because I don't have x.
Oh.
Only with x would have been negative 3. There is no x. That means that for any value, y is 3. The first ordered pair from left to right, negative 1 comma 3, full point. But then 0 comma 3, what type of point? Very good. Now the other branch, 0 comma 0, this is a full point. And 1 comma 1, and so on and so forth. So this is our function, f of x. As you see, it has a gap, or a jump, we call it. Okay. Can anyone identify the range of this function? Excellent. Because this goes all the way. Very good. So the range is indeed 0 to infinity. Any questions? Okay, let's look at one more, and we can move on. So let's say 43 on the same page, 194, f of x equals x squared for x less than 0, and x plus 2 for x greater than or equal to 0. Like before, I will look at this and see negative infinity to 0. I will look at this and see 0 to infinity. I will identify the domain one more time. What is it? Yeah, it happens to be. It will not always be the same. Just keep that in mind. And then negative infinity to infinity, and of course we have to have 0. Look at the symbols now. Parenthesis to the left and bracket to the right. Parenthesis to the left under 0 and touching a bracket to the right. Which function we use between negative infinity and 0, and which function we use between 0 and infinity. Yes? For the first part? Very good, awesome. For the second part? Great job. So now, because this is quadratic, let's plug in -2 and -1. So when we plug in -2, what do we get? Excellent. When we plug in -1, awesome. And when we plug in 0, and we shouldn't, you should say, but you know what's going to happen. 0. 0 on the other side, 2. And let's put 1 on the other side. Great job. Well done. So then from left to right, the first ordered pair. -2, 4, the next ordered pair. And the last ordered pair, this one. 0, 0, open. Well done. Remember, this is quadratic. It's half of x squared. We're done with the left branch of 0. Now 0, 2, right here. Full point, correct? And 1, 3. So this is the function f of x. Notice that branches cannot be extended. X squared is only between -infinity and 0. And x plus 2 is only between 0 and infinity. Can anyone give us the range of this function? With a parenthesis, 0 to infinity, because this is not a full point. Very good. Yes, please. 194, right here. 43 on page 194. Good. So now we have some work to do concerning domain. So all these functions, pick anything you want, and let me know what you would like to determine the domain for. So we want to pick 19? 19? Okay, anything else? I think we should also pick either 21 or 23. 19 is perfect. Either 21 or 23. Which one? Okay, so 19 and 23, page 193. So 19 and 23, page 193 from the book, of course. So the first one is, I'm going to move to the next page. Any questions? Any questions? Please ask. Anything. Always stop me if you have questions, please. Anything? Okay. Here's 19. F of x equals 2x cubed minus 250. Everything divided by x squared minus 2x minus 15. For the following exercises, find the domain of each function using interval notation. And I'm going to copy 23 as well. So it's f of x, the square root of x minus 6, the square root of x minus 4. So I can put this aside. Very good. So what type of function is this? We solved equations a long time ago. We know what function this is. Rational, very good, awesome. What is the danger? There's only one danger with rational functions. What is it? Say it again.
If you take like the cube root of things, right?
Very good. So x squared minus 2x minus 15 cannot be 0. We're talking about domain. So the only restriction we have to state and solve is this equation. Can anyone give us the factor form?
X minus 5, x plus 3.
And x plus 3. Very good. So there are two options. X cannot be positive 5 and x cannot be negative 3. But they want us to present the domain. So how do I write the domain?
negative infinity
Yes?
to -3.
Very good. Awesome. Union.
-3 to -5.
Very good. Awesome. Positive. Yes. Great job. Excellent. This is the way we write a domain in interval notation. Excellent. Thank you. Thank you. Yes. Well done. Now, when we look at 23, if you have questions, please stop me. Let's discuss this function now. So what do you think about it? What is it? Well, the answer is a combo. You can't say what it is. I can't say what it is. I can only say that it's a ratio of two radicals. Good. So I'm logged out and I'm getting ready to take attendance. Okay, so I have to have a restriction for this. I have to have a restriction for this, and the denominator cannot be 0. So for this piece to exist, what do I have to write? X minus 6 greater than,
Or equal to.
thank you. What about this one? For this radical to exist and the fact that it's in the denominator, I have to write that x minus 4
And equal to 0.
has to be greater than 0, but not equal to 0 because that piece is in the denominator. Very good. So then I solve the first one as greater than or equal to 6. I solve the next one as greater than 4. And now I have to intersect the two domains. So you don't have to graph. I just want to graph it one time. So greater than or equal to 6, bracket, greater than or equal to 6. I don't care for units. The graph is not an accurate graph. It just tells us what to write. So, and this is 4 with a parenthesis. And I need to choose that portion of the real line that has both colors in it. In other words, both conditions are fulfilled. Where? That's it. So the domain of this function is 6 to infinity. Because if I choose here, only one of them will exist. If I choose here, none. I have to choose where they both exist, or both conditions are taken care of at the same time. Any questions? So let me show you where we are. So this is accomplished, it's done 3.1. Domain and range 3.2 is done. I have not gotten to 3.3. And we selected problems for everything that was recommended. So just, we have 3.3 and beyond. Yes.
What the lowest gonna be?